is flip-flop using NAND gates and flip-flop standard IC 7476. This is a standard IC that we are going to discuss. Okay, so in this the first we will do that, and then again we'll realize this JK flip-flop and D flip-flop and T flip-flop. So these three will realize the truth table for the design and realizing these three flip-flops, JK, D and T flip-flops. So this experiment. So what we are doing today's experiment is experiment 5, a truth table verification of a flip-flop. Okay, in that we will discuss the flip-flop using NAND gates and flip-flop by using standard IC, that is 7476, and in that by using this we will implement this functionality. The first we will implement the JK flip-flop using NAND gate, D flip-flop using NAND gate, T flip-flop using NAND gate, and then the implementation of the JK. Actually this is the IC for JK master slave JK flip-flop. So this is a standard IC for master slave JK flip-flop. Even you can implement using this by little modification to form a D flip-flop and T flip-flop that we are going to discuss today. Okay. Now we will start writing designing the JK flip-flop using NAND gate. JK flip-flop using NAND gate. So how the JK flip-flop implementation we have done using NAND gate? There are two cross-coupled NAND circuit is connected. One is a master and another slave, right? With the clock that we are going to design now. Okay. So this is the first JK flip-flop with a NAND gate, another JK flip-flop, sorry, NAND gate, another NAND gate, and these two are connected for a clock input, and you have to consider this as a J input and this is a K input. Now you have to use a cross-coupled for element cross-coupled circuit to perform the memory. For first JK, this is called a master JK cell. Okay. And here you have to use this is for preset input, and you have to use this is for clear input. Right? Then after that we have to, this is a, you can say this is a master circuit, and now we have to design the slave circuit. So why we have to need the two JK flip-flop connected as a master and slave? Because to overcome the race around condition. And this is the input here, and this is another input, and here same way here we have to connect these two and connect it as a clock input. With in between we have to place a inverter. Again inverter is also implemented using NAND gate. Okay. Then we have to use the the cross coupled circuit. That is okay. So to work on the race around condition, the Q output should be given to as an input along with the K input. The Q output is, the Q is here, this Q is given to the ANDed with a K input. So where is a Q? See, you can say this is a Q and this is a Q bar. Okay. So Q you can take from Q here in this side. Okay. Then Q bar is a ANDed with the J. So it curve indicates that there is no connection here. Okay, just the wire is not connected in this point. Okay. So this is the complete diagram for a D flip-flop already we designed. Now we have to implement on the trainer kit. To implement the trainer kit, what type of gates we required? The NAND gates are all are implemented using NAND gate. NAND gates are required. So what type of NAND gate? So here this is a 3-input NAND gate, 3-input NAND gate, and but here the 2-input NAND gates are there. So there are 4 3-input NAND gates and 5 2-input NAND gates are there. See 1, 2, 3, 4, 5. Okay. So now we have to find out the which IC can be used to implement 3-input NAND gate. So IC for 3-input NAND gate is the pin configuration for 3-input NAND gate is here. 3-input NAND gate is. Okay, could you able to see the diagram here? So I will draw the diagram for the. You have to refer the data sheet for the 2-input NAND gate, right? 3-input NAND gate. Okay. So I will draw here for you to see the clear diagram for 2-input NAND gate for your reference. If you are able to see the screen, right? To be able to see this one, see 2-input NAND gate here. So what is the pin number for 2-input NAND gate? Input pins are 1. So 1, 2, 13 are input and 12 is output. Like there are the IC is 7410. The IC for 3-input NAND gate is 7410. So this 7410 having the integrated with the 3 NAND gates, 3-input 3 NAND gates are there. So here, see, you can see 1, 2, 3, and this is a 14-pin IC. This is a 14-pin IC, and it integrated with 3 NAND gates, 3-input NAND gates. So another, we need 2-input NAND gates also. For 2-input NAND gates, what is the IC number? IC number is 7400. So 2-input NAND gate IC number is 7400 here. And this 7400 IC, the 4 NAND gates are integrated within this 7400 IC. Right? If you use this IC, you could be able to access the 4 NAND gates. For 3-input IC gate, 3-input NAND gate IC, that is 7410 IC, you could be able to access the only 3 NAND gates. Right? So this is the pin configuration for the ICs for different gates, NAND gates. Right? The 2-input NAND gate for this is 7410, and 3-input NAND gate is 7410, and 2-input NAND gate is 7400. Okay. Now we have to use excess, we have to take the gates from the particular IC. So we have 4 3-input NAND gates in this design, right? So, but this IC, one IC, if I take, for example, if I take one IC, that IC will have only 3, but we need 4 NAND gates. Either what you can do is you can use these 3, 1, 2, 3, you can use from one IC, and another one gate you can take from the second IC. Or what you can do is you take 2 from one IC and you take another 2 from another IC, whatever you can, and you can leave the one gate not connected, right? So this is how you can do. So the next step is we have to specify the pin numbers for all inputs and outputs of this gate. Okay, so this is the IC 7410 IC 1, and this is 7410 IC 1. I will take these 2 gates from IC 1, right? Then what is the pin number? I will take the pin number, I will take this gate, okay, and this gate, right? What is the pin details of this gate? 3, 4, 5 are the inputs and 6 is output, right? 3, 4, 5. So I will write the pin number 3 and 4 and 5. Can you able to see? This is pin number 3. I will write here 3, 4, 5. And the output for the first gate is 6. I will write pin number 6 here. And similarly,
the printed paper is not clear.
Which one? This one, huh?
Yeah.
Yeah. I will draw the pin diagram if you require. So just I am telling, right? Just for NAND gate, 2 input NAND gate, what is the pin input? 1, 2 are input and 3 is output, right? So in this case, the first gate I will draw here. If you are not able to see, I will draw here. Okay. So this is the pin configuration of 7410. So this is the pin 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 11, 12, 13, 14. Okay. So 14 is VCC and 7 is a ground, right? And pin number, the one NAND gate is pin number 1, 2. Pin number 1, pin number 2, and pin number 13 are inputs, and pin number 12 is a output for this, right? Then second NAND gate is pin number 6 is output. The pin number 3, pin number 4, and pin number 5 is the input for the second NAND gate. And the third NAND gate is pin number 8 output, pin number 9, pin number 10, and pin number 11 is a inputs. So this is the data sheet roughly I am written here, right? Now you could able to understand this connection, the data sheet details of this pin, right? So I am utilizing these 2 gates from the each connection here. So 3, 4, 5. So this is 3, 4, 5, and 6 is the output. 6 is the output. Then the next is 8 is output. 8 is output, and I use another sketch paper. So then the 3, 4, 5 Another pin for the second IC is 4, 5, 3, 4, 5, and 6 is output, and then 10, 11, 9, 10, 11 are input. See, you can write 9 and 10 and 11. Okay, so 9, 10, 11 and 8 is the output for this. Then second, I will take the IC. This is I will take two NAND 3 input NAND gate from one IC, and the second IC I will take IC2, and this is also IC2, and this is also 7410 and 7410. Okay, 7410 from the second IC. The two IC I am using because 4 gates are there. Either you can take these 3 gates from one IC and one from the second IC. For convenient, I am using 2 from each IC. This is the first IC and this is second IC, 7410, 7410. Okay. Then the pin number. Here also the second IC, I can use 3, 4 and 5 and 6, second IC, and this is 9, 10 and 11 and 8 output. And similarly, now we have to use the 2 input NAND gate. That IC is 7400. IC, only one IC is required for this, for these 4, because the 7400 is 4 NAND gates are integrated into the 7400 IC. So that's what, only one IC is required for this. And pin configuration is first gate I can use 1 and 2 input and 3 output, and then even you can see the diagram 7400. See in this here you can see 7412 is input and 3 is output, 4, 5 is input, 6 is output, and 10 and 9 are inputs and 8 is output, 13, 12 is input, 11 is output, right? So 1, 2, 3, and then to access the second NAND gate, the pin second NAND gate in the IC 7400 is, you can write 4 and 5 inputs and 6 is output, and third NAND gate is 8 is output, and the 9 and 10 you can use 9, pin number 9 and pin number 10. And these are all IC 740. Only one IC is there, 7400, 7400. Only one IC, 7400. IC1 you can write IC1, IC1, IC1. Now IC1, IC1. Okay, you can write IC3. 1, 2. You can write 3. IC3. This is IC3. IC3. Okay. Then this is a 9, 10, 8. Then this gate is 11 and 12. I'll write 12. 12 here. 12, and this is a 13. 1, 3. Okay. Now there is one more NAND gate. You can use second IC, one more IC for NAND gate 7400 for this, and 1, 2 and 3. So total how many IC we are using? 7410, 2 ICs, and 7400, 2 ICs, because this is a one IC and this for one more NAND gate is used and one more IC is required. The total 4 ICs are required here. Okay, clear? So now we have to do the connection. You can check the circuit board, trainer kit circuit board is connected with the power by just checking, pressing the here back button, and even you can make on any input switch. You could able to see here, right? You can check anyone. So already we know that the holders for ICs. So in this circuit already we mentioned, right? This is the first IC, this is the second IC, and this is the third IC for that all 4 gates, and this is the fourth IC for one single NAND gate, right? So same way I have inserted the this is the 3 input NAND gate, first IC, 3 input NAND gate, second IC, 2 input NAND gate, third IC, and 2 input NAND gate for between the inverter, used as an inverter. This is the one extra IC. So here mainly we have to do the connection from this, right? Already you know that the IC, how we have to insert and do the connection. So each IC should be connected with the ground and VCC. So before start doing the connection, you have to give the VCC end. So all ICs are 14 pin ICs. All ICs are 14 pin ICs. So here the holders for these ICs, like this one are 14 pin holders. Right? You can insert 14 pin. See, this is 16 pin. This is 16 pin.